Now, Chapter 3 of Cryptography class. We have Chapter 3, Traditional Symmetric Key Ciphers. Now, before saying anything, I want to tell you to please pay attention to the classes because the cryptography classes kind of have mathematical computations. So you need to be aware of the mathematics so you get the entire idea. Now, our challenge would be to break this code. Now, in order to break this code, you have to know in which algorithm this has been written, which I will not tell you because you gotta understand the class and then you should break the code. And after this, this is cryptography. When we have symmetric encryptions, we have asymmetric encryption, and we have hash functions. Now, for the hash functions, we have MD5 or SHA secure hash algorithms or others. We may have a lot. Now, for the asymmetric encryption, we have the private key, and for the private key, we have the block ciphers and we have the stream ciphers. Now, the block ciphers, just like DES or AES, Oblowfish, or many more. However, in this side, we will have a symmetric encryption. Symmetric key, symmetric encryption has public key, and the public key would be RSA, Def-Hellman, or others. In our previous class, we talked about the RSA and Def-Hellman. We said that we have a public key and a private key. Why this has been categorized as a public key? Because we can use the public key in order to encrypt something, and then that the recipient or receiver will have his own private key and can decrypt it. Now, for the private key means that we are using the one key or one private key. Now we will dive in. This was just a category, and this would be our objective. First, to define the terms and the concept of symmetric key ciphers. So it is more than one, actually. It's like 9 to 10 ciphers, symmetric key ciphers. And emphasize the two category of a traditional cipher, substitution and transposition ciphers. Now, to this also, we will try to describe the categories of cryptanalysis uh, that used to break these symmetric ciphers. Of course, those symmetric ciphers that are easy to understand and doesn't need any computational power in order to break the code. Now we will introduce the concept of a stream cipher and a block cipher. Of course, if we reach this one, which is the from the near slide of 52 to the end of the slides, and then discuss some very dominant ciphers used in the past, just in Enigma machines. And first of all, an introduction. In figure 3.1, which is this figure, and now we will take a look, shows that the general idea behind symmetric key cipher. The original message from Alice to Bob is called plaintext. The message that is sent through the channel is called the ciphertext. To create the ciphertext from the plaintext, Alice uses an encryption algorithm and shared secret key. To create a plaintext from the ciphertext, Bob uses decryption algorithm and the same secret key. Well, this is text. However, with the illustration, you will get the points. And now we will explain it. Before going any deeper, topics that will be discussed in this section would be Kirchhoff principles, cryptanalysis, and 313 categories of traditional ciphers. Now, what I explained in text, in here I will explain it in using this illustration. This is the general idea of a symmetric key cipher. Alice and Bob. Now, Alice has plain text or the message that she wants to send Bob. She will encrypt it using an encryption algorithm. using a shared secret key. So both Bob and Alice have this key. They shared it. How did they do? They did it through a key exchange channel, through, let's say, face to face. Anyhow, they did it. Now, from the plain text being encrypted, we will have the ciphertext. It is uh, the way that it should. Encryption algorithm and then the ciphertext. Now we will send the ciphertext through insecure channel. Can you give me one example of an insecure channel, or what do I mean by insecure channel?
A program or something that does not provide encryption so that
Mhm.
the data can be just transferred and can be uh, seen if the packets are captured.
Okay, thank you very much, Mr. Bjard. In order to send a data to me, what you will use?
Protocol.
And through which technology would you send me this? Uh,
Application.
th through internet. Is it right? You
Yes.
you will you have a message. You want to send me that message. You will use internet. Is it right? Now,
Yes.
internet is insecure 100% because in internet everyone is out there, and anyone could be the person that want to intercept your messages. Now, I have a plain text. I encrypt it using an encryption algorithm with a key, and I have the ciphertext. Now, I will send this ciphertext and through all the way to Bob, or Alice will send it to Bob. Now, Bob got the ciphertext, and Bob know which algorithm Alice used, so he will use the decryption part of it. And of course, he has the key. Now he will get the plain text. Okay, so Alice sends a message before she encrypted using this key, and now has the ciphertext. Ciphertext being sent through internet. Through internet, Bob gets the message, and from that from that uh, message, from that ciphertext, he will decrypt use the decryption algorithm and decrypt the message with the key that Alice and Bob they have together. Now he has the plain text. Now let me choose a laser pointer. Yeah, this one's better. Now a plain text being encrypted, converted to ciphertext. The ciphertext. The ciphertext being sent through internet to all the way to Bob. Now Bob got the ciphertext. He will use the decryption algorithm with the specific key, and he will get the plain text. So this is mainly the general idea of encryption and decryption. However, our point in here would be on encryption algorithms and decryption algorithm and the key. It will not be through how to send or exchange the key. It will not be about the insecure channel, which is internet. It will not be the package or packet header of the packet that we will send as a ciphertext. Nothing like that. This is the job of, let's say, internet networking class or the other classes. Now we will talk about the encryption algorithm and decryption algorithm and the secret key. Now, if P is a plain text and C is a ciphertext and a K is the key, okay, the encryption would be C means ciphertext, or in order to get the ciphertext, we need to do this. Normally, we will read it through here. However, I will tell you from here how. I'll say in order to encrypt a message, you first have the plain text and you will encrypt that plain text. However, using what? Using the key, using the key. You will get a ciphertext. Now, how about the decryption part? We will have the ciphertext. Now, someone send me the ciphertext. I have the ciphertext. I'll try to decrypt it using the key. Then I will get the P. Now, in which decryption using a specific key for an encryption of a message that has been encrypted with the same key would be equal to encryption of the decrypted cipher with the same key. Okay, and it will be equal to the message. Now, this part means that the decryption and the encryption, they should be equal. Okay, because this is symmetric and the things are equal. Even the key is equal, and these two part encryption and decryption need to be equal. We assume that Bob creates P1. We prove that the P1 is equal to P. Now Alice is C equal to encryption of plain text using the key. Now Bob is equal to Bob is P1 as he creates P1 or plain text 1 is equal to decryption of the ciphertext using the same key would be equal to decryption of the encrypted plain text using the same key, and it would be equal to the plain text. So that's why when I say the plain text or ciphertext or a key, I mean this. This would be the plain text or the original message. The ciphertext would be the encrypted message, and the key would be this key. So that's why it is important to understand these terms. If you have any problem with these plain text or ciphertext or the key and you don't understand, please speak up now. You have any problem with these words, guys?
Uh, what's the X?
No, I mean, you should understand the plain text word, ciphertext word, and the K. What does they mean? Because in here, from now on, we will use ciphertext, plaintext, and the K for the key. So if you don't know what are they, you should ask so I can explain it again. And I have explained it in here. This is plaintext, this is ciphertext, and this is the key.
No, I know that, but what I don't understand is the X. What does it stand for?
X is the message.
Ah,
A message, let's
okay.
say, yeah.
Thank you.
You're welcome. Now, this is figure 3.2, locking and unlocking with the same key. You see in the symmetric, we will use the same key. Okay? Same key for encryption, same key for decryption. And based on Kirchhoff principle, one should always assume that the adversary or Eve would be an adversary or the person that want to hack us, let's say, knows the encryption and decryption algorithm. The resistance of a ciphertext to attack must be based only on the secrecy of the key. What does it mean? It means that Mr. Bowen should always consider that uh, the encryption and decryption algorithm is always out there and everyone knows it. However, he need to make sure that the key will not be exposed. No one knows that what is the key. So in the symmetric, you should be uh, able to secret the key to make sure that no one will know what is the key. This is Kirchhoff principle says that the encryption and decryption everyone knows what is it. However, the secrecy of the key is the point that you need to make sure. Now we have something cryptanalysis. Cryptography, our class, is the science and the art of creating secret codes. Unfortunately, or fortunately, can be used for good and bad things. So cryptanalysis is the science and the art of breaking those codes. So cryptography secure the code or create secret codes. Cryptanalysis try to break it. Now we have 3.3 cryptanalysis attack and we have 4 types. Now ciphertext only, known plain text, chosen plain text, or choosing ciphertext. Now, what does each one mean? We will explain it. Now, the ciphertext only. Alice will send the ciphertext, okay, to Bob. Bob gets the ciphertext. However, Eve is in this between. This is the hacker in this between. She, Eve will get the ciphertext and she will try to analyze it to get the plain text. Will she would be successful or not? This is the topic for another chapter. However, in here, she will try to analyze the ciphertext. Now, known plain text. Alice wants send the ciphertext to Bob. Bob get the ciphertext. However, the ciphertext being intercepted by Eve also. Now, Eve will try to analyze it in order to get the plain text. However, unfortunately, Eve was able to get the previous pass or get this previous ciphertext. She cracked those and now knows the understand the pattern that I use or Alice use. So now Eve will try to analyze the before ciphertext to understand the known for the known ciphertext. Okay. So analyze it. What do I mean by analyze it? She get the previous pairs. She analyze it. Now understand the pattern that I use for encryption and decryption. She will get the ciphertext and analyze it to get the plaintext. Now a chosen plaintext. Alice sent the ciphertext to Bob. However, again, Eve intercepts it. Intercept the ciphertext and analyze it in order to get the plaintext. However, how does it analyze it? Now you see Eve per send it Alice a plain text. Now Alice send it the ciphertext. Okay. Now she will get those chosen plain text in order to analyze this plain text of now. Now has plain text, have a lot of plain text, and knows the ciphertext of them. So she will try to analyze the pattern that Alice is using. Now, how about the chosen ciphertext? It is the uh, opposite of it. Now, once Alice wants to send the ciphertext to Bob, she intercepted, analyzed it, and the plaintext. Now, how does this analyze works? It would be pair created from the chosen ciphertext. She created the pairs from the chosen ciphertext, and now with the plaintext, now she will analyze it and understand it. However, this side would be from the Bob side. The chosen plaintext was from the Alice. Now, 3-2, we have substitution ciphers. Now, if you have no questions about the before, we will start with this. Okay, I assume that you have no questions. So now, substitution ciphers. Substitution ciphers replace one symbol with another. Okay, this is the main idea, guys, because we will also have the transposition or rearranging the texts. However, no, in substitution, we will change A to B. Okay. However, in transposition, which would be the other part, we will have A in here. Let's say we have E in here. We will change its place to C or into here. Okay. So substitution وش كان غوري أين بوكا ببي إسكا بجي وإلى آخره بلام transposition شو أنا كان أنا غوري وانا اس لا بوزيشني سي ليرا يك دو سي ليروي غوريبو إيرابونونا. That is the main idea. Substitution ciphers can be categorized as the either monoalphabet cipher or polyalphabet alphabetic ciphers. Now, the topics that we will try to talk about would be monoalphabet ciphers and polyalphabet ciphers. Now, monoalphabetic cipher, we have a note. In monoalphabetic substitution, the relationship between a symbol in the plaintext to a symbol in the ciphertext is always one-to-one. What do I mean by this? I mean that, for example, I have a ciphertext, and the ciphertext has X, for example. The X in this example will be always A in the plain text. It will not be changed. Now we will also take a look at here. Now we have example 3.1. The following show the plain text and the corresponding ciphertext. Now hello became KHOOR. Don't tell me what is the encryption that has been used. This is only a simple example. Okay, we are not talking still about the encryption algorithm and so on. Now you see that corresponding ciphertext, okay, the cipher is probably monoalphabetic because the both I's ELs are encrypted. Actually, this is not I, sorry, this is L's being written this way. We have hello, HELLO. If you take a look at LL, it mean in here we have OO. Okay. However, in this example, we have HELLO, but in here we have KHMAR. You see the L and this L, the first L would be M, the second L would be A. This is what does it means when it says mono alphabet substitution is one to one. Okay, it means that L would be always O, will not be changed. So this example in here is not mono. Okay, we will say in here we say mono or poly for for easier saying. So mono is this LLOO. Non-mono would be L would be M. The other L is A. Now did you got the point؟ برزان لا فكرك يتيجيشن
Yes.
Yes.
هنيك جار بويزيات الروني أكم والله منوكتي أنا جيش بيتن okay. Now we have mono and the poly alphabet. Mono alphabet, poly. So I would say from now on, mono or poly. Now this was mono, this was poly. How about the additive cipher? In exam, if I told Mr. Bawan use additive cipher, and if I told Mr. Muhammad Kamal Caesar cipher, and I will tell Mr. Bishar to use shift cipher, they are all the same. So Caesar cipher, shift cipher, or additive cipher, they are all the same thing. However, this technique has three names: Caesar cipher, or shift cipher, or additive cipher. Well, this part is the simplest monoalphabetic cipher. Okay, لا سيزر cipher هيك لا cipher كان لا سيزر أسانترني and it is they say that it is the first cipher the first encryption and decryption algorithm that ever been used, and the idea is quite simple. We have A small with the A capital, and B, B, C, C, and so on. This being written in here, the ciphertext, it is not the ciphertext. It is again just the capital and small, nothing else. And this actually this is from the book. That's why I didn't change it. However, this is the only just the alphabets. Now يكشت هي هتجيز لبيرت عن نتشي لدني كريبتوغرافيا لسفرو دس بك هروكو قريب. Now A has the position of 0, B would be 1, C would be 2, D is 3, and E is 4, and so on. All the way we get 25. However, in real world, we say 1, 2, 3, 4, 5, 6 until we get 26. But in cryptography, start from 0. Just be aware of that because you will get in trouble and you will not be able to decrypt the message if you didn't count this. Now, in our previous class, I explained what is Z26 means. Okay, and I said that in Z26, the numbers will start from 0 However, in Z asterisk, they will start from 1. Okay. Now سرتان بمو مشغول ناكم سرتان بو ناشن ومشغول تان ناكم بوي ك Z و Z asterisk ياخد Z ئەستێرە چییە؟ باسمان کرۆ لە ڤیدۆکەی پێشوە ئەگەر پێویستی دەتوانە بچن سێری بکەنەوە ئەگەر پێویستی شکل لێرە باسیەکەینەوە. However, just so you know. Now, additive cipher, how does it work? We say that the C is equal to P plus K. Now, Mr. Bja, what does the P stand for? Or what is P in here? What do you think? Mr. Bja, are you here? Guys? Mr. Bja is not here. How about you, Mr. Bowen?
P is the plain text.
Is the plain text plus the key mod 26. We will have the ciphertext. This is the easiest one. Thank you very much, Mr. Bowen. Now we will get the encryption and we will have the ciphertext. We will send it to the Bob, and Bob will get to decrypt the algorithm using the decryption algorithm, and he want to get the P plain text. How? From the ciphertext minus the key mod 26. Now, one simple note: when the cipher is additive, the plain text ciphertext and a key are integers in Z26. La کاتی cipher additive زێدی 26 بەکارێنین بە مانایەکی تر لە ژمارە 26 گەورەترمان نابێت. هیچ ژمارێکمان نابێت لە پۆزیشنی ئەمانەیە لە 26 گەورەتر بێ. And now we will explain it why. Okay. Now let's take a look at this. Use additive cipher with the key 15. Now we know the key is 15. Okay. I want to encrypt hello. How would I do that? First, of the plain text, I will take the position of the each letter. Now the H is 7. Now let us check. Where's H? H is in here. H is 7. Where's E? E is in here. 0, 4. And L, 11, 11. And what about O? 14. Now let's take a look. Yeah, 7, 4, 11, 11, and 14. That's why I said you gotta be aware of that in cryptography we start from 0. Otherwise, you would have said that the E is 5. That would not be true. Now we have the position of each one. We will encrypt it. How? We say that the position is 7, 7, and the key is 15 plus 15 mod 26. Now this would be 22 mod 26. Now, Mr. Bowen, we talked about this. We said how we will do this. Is that correct? Bastian Manker?
Yes. Yes.
Now you know how to do it. Is that correct?
Yes.
Okay. And I will do only one for you, just so you know. Let me use Notepad. I would say that 7 plus 15. Let's put it in here. Okay. Mode 26. I think it's small. Now you can see, right? Now here is 22. Mode 26. Now what should I do? I'll say that 22 is equal to 26 multiple something multiplied by something plus something. Now in here, I will say that I will multiply this by 0 and I will add 22. Okay, so this is the reminder. This is the what I want. Now, if you could see that 7 plus 15, 22 more 26 would be 22. Okay, now did you got the idea? يعني هيش برسيارك نية؟
That's
You're welcome. Actually, sorry, I call you a lot. However, I just want to make sure that everyone understand it. Okay, from now on I will call Mr. Muhammad Kamal. Now, encryption for the E would be 4 plus 15 or 26 would be 19. 11, 15 would be 0, 0, and 0, 3. So if we used key 15 to encrypt message hello, we will get WTAAD. Okay. Now, how if I wanted to decrypt it? Now I know the key is 15, and I will get the ciphertext 22, 19, 0, 0, 3. I have the ciphertext. I will try to decrypt it. Now this time I'll say 22 minus the key. 22 minus 15 more 26. It would be 7. 19 minus 15 more 26 would be 4. And until we reach the last one. Now, if there's no question, we will go to the shift cipher. No question? Okay.
No, thank you, Doctor.
You're welcome, Mr. Bashar. I called you actually. I wanted to see if you have any question or something.
Actually, I was watching, but I didn't hear you.
You didn't hear. Okay, no problem. Now, shift cipher and Caesar cipher. Historically, additive cipher are called shift cipher. Julius Caesar used an additive cipher to communicate with his officers. For the reason, additive cipher are sometimes referred as a Caesar cipher. Caesar used the key of 3 for his communication. So this is just the historical part of it. Okay. Now, additive cipher are sometimes referred as a shift cipher or Caesar cipher. إترى منظور دوباره كده. Now, Eve has intercepted this one, the ciphertext. Eve is the hacker. Eve o kaseke ewe text agora bagre tu bzane meschaka cheatia. Okay. Show how she can use a brute force attack to break the cipher. Okay. The first of all, Eve tried keys from 1 to 7. Okay. She just guess. Says, well, I will choose from 1 to 7. I will use these keys. If I got it, okay. Otherwise, I will start from 7 to 14. Now you see she got the ciphertext. She will use the key and the plain text would be this. What do I mean by using the 1? I mean one time shifted backward. یک جار بقريته دعاء. Two times shifted backward and until she reached number 7. Now she understands what is this. Now if we read this one, opus this stdvscf, nothing you can understand. However, in here, not very secure, you understand that this is the word. Now we have something that you need to be aware of it, and it is that the letters have frequencies. Now, for example, E has the highest frequency in a sentence. Nearly 12.7 of the times you would see a letter with E. Now, the T is the second one, would be 9.1. A is 8.2, O is 7.5, all the way until you reach Z. Now, we have something else, the frequency of diagram and trigrams. Diagrams means that th, he, n, er, n, re, ed, on, es, and so on. Now the trigram would be the, ing, and here EREENT, THA, for example, than or that, and so on. NTH was ETH for DTS. Now this is the trigrams. Example 3.6. If has intercepted the following ciphertext using the statistical attack. Find the plain text. You might say that, well, Eve will take this part, let's say 1, 2, 3, 4, 5, and she will take this and she will try to all the keys and so on. However, no, there's something else. If tabulates the frequency of letters in a ciphertext, she got that I is equal to 14, V is equal to 13, S is equal to 12, and so on. Now, the most common character is I with the 14 occurrences. This means the key is 4. Why is that? Because we said that the E has the highest frequency of occurrence. زورترین که دوباره بتو. And if you take a look at E, you would get that the key is 4. So that's how Eve will understand the additive cipher. So she says, well, actually, I think that the I's are, because it has a lot of occurrences, I think that the key is 4. Now, once she uses key 4, she will get this message. The house is now for sale for $4 million. Is it worth more, Harry, before the seller receives more offers? Now, نەهات بۆ ئەم بەشە وەربگرێت و کلیلەکان لەسەر تاقیکاتەوە هادووتی ئای زۆر دووبارە بۆ تۆ و ئەگەری زۆرە ئی بێت باش کلیلی 4 بەکارێنم. Now that she used the key 4, she got the message. Okay. Any question until now, guys?
No, ساقي
أستاذ بس شو يعني كي رقم شوارع؟
She count the numbers, the number of occurrences. Now I has a 14 times occurrence, and we said that the most occurrence letter would be E. أو شيء لزمانی ئینگلیزیە زۆرترین کات دووبارە بێتەوە ئیە لە سەدا 12.7 جارەکان ئیە. She guessed it. يعني guessy کرد. Okay, let's use key number 4. جا لەوانێ بڵێ ئەگەر کلەکانی تێ بکارێنە. Now, yes, she could use all the other keys. کیەکانی تریشی ئەتوانی بەکار بهێنێ. بەڵام شتێک هەیە لێرایە. تۆ لە جاتی ئەوەی 26 کی بەکاربێنی ئەتوانی بە سێکی بە تەقریبی بیدۆزیتەوە. طبعاً سێکیەکە بەکارێنی هەرچەنە ئەگەریشیە سێکیەکە جوانە بێ. بەڵام لە حاڵەتی additive cipher is correct. Like 95% of the time it is correct. Okay, and you might say, well, it's correct. I has the occurrences of 14 times. Now, I would say that the most, let's say that the I is 2 times and the V is 14 times. Now, I would say that the key was 4. Why? Because it has been changed. چه ئەو شەی کە زۆر زۆر دووبارە بۆتەوە بە ئەگەری زۆرۆ ئیە is E. Why? Because E is the highest frequency. Now the second highest would be 9.1 would be T. In this case, V is 13. Okay. However, we will choose the first one. However, if it was not the first one, we will try with the second highest, and we will use.
يعني بو معناه هم سرتا بچوار دەست پێ بکەین.
No. ئەمە analysis کردنە. کاتێک کە analysis ئەەکەی ئەو سایفەر تێکستت کە دەستکەوتووە بە تەقریبی سێرێکەکەی بزانی کچ و شێک زۆر زۆر دووبارە بۆ تۆ.
باشە بەس ئای زۆرترین جار دووبارە بۆ تۆ لەو سایفەر تێکسی سەرەوەیە.
باش
ئەگە سێریگەین ئی هەرتیان نییە. بەڵام ئێمە
سەگەت چییە؟ سەگەت چییە؟
باڵی یەکەوە دەگرین
ئێمە
کە چوارە.
اوكي اما الين توقعي اواكن كاي اي بيت جا لەوانێ بڵێ ئەی چۆن تەوەقعت کرد ئەڵێن بە پێم تێبڵە لەبروی ئەڵین زۆربەی کات لە زمانی ئینگلیزیە ئەو شانەی زۆر دووبارە بنەوە ئیە یەکەم دانە so we will use e
باشە ئەگەر ئێستا بچیتەوە سەر ئەمە دوای ئاەکە بۆ نمونە ئەگەر بوو ئایا پێشبینیەکەمان ڕاست دەرنەچێت
we will use
دوای
the
بوو
second one which would
ئەڵێن
be
VE ئەو
no
کاتە ئەڵێن
no no
ڤیەکان
no we will say that the t now we will look at the position of t and we found that the t is 19. Now we say the 19 is the key. We say that the suggestion is the 19 is the key. It is not 100% sure. هیچ شتێک لە دنیای کریپتۆگرافیا 100% نییە بۆ کەگە 100% بێمانەوە هەر کیەکەت لای already تۆ بە شوێنە ناگەڕێت تەوەقوعەکەی okay and then so on so this is how the person or the Eve will try to decrypt the message. First, she will use E, position of E for the key, and then for the T, and for the A, O, I, N, S, and so on. If she didn't reach it, she will use all the keys. Now, she cannot understand it. It is not like additive, and this will work for additive actually. This is for the simplest one.
باشە مامۆستامە ڕۆژانە بۆ نمونە ئەپلیکیشنەکان کە بەکارێنین یا هەر شوێنێک کە بۆ پەیوەندیکردن بەکارێنین خۆیمان هەر پیتی ئینگلیزی بەکارنایێنین ئەی بۆ زمانەکانی تر چۆنە
ئێمە ASCII کۆدمانەیە. Do you know that? Is that correct?
بڵێ
Yeah. ئەو کاتە ئاسکی کۆدەکانیان بەکارێنرێ ئاسکی کۆدی بۆ نمونە ژمارەیەک ئێستا ئەی کە لە زمانی کوردی خۆمان ئەگەرمانێ ئۆ بنووسین بە یونیکۆد بنووسیت ئۆ وەکو بۆ نمونە ناوی کوردۆ ئاخیرەکەی ئۆیە هەر بە ئینگلیزی بنووسی ئەڵێ KURDO ئەگەر بە کوردیەکەی بینوسی ئەڵێ KURDO ئۆکە هەر ئۆیە لاوە ئاسکی کۆدەکانیان یەکشتە وایە
بەڵ
so بەو جۆرە هەر ئینکریپشن و دیکریپشنەکە کرێتەوە.
دەست خۆش
You're welcome. And now, is it clear, Kak Mohammed, that you got it? So ASCII code موضوعك يعني وشكا أما بو آسانية أجر آسان نبي بو لجاتي بلين إي بلين ASCII كودكي بلين إي ASCII كودكي وفريكونسي كش ماربي و ASCII كودرش ماربي شماركان زور تكلبن هر بوشة DNS هي DNS يجالت يلا جمارة أو 92.168 ژمارەیەک قورسە بۆ لەبەرکردن بەڵام www.google.com ئاسانترە بۆ لەبەرکردن. That's why we use this. You're welcome. Now she guessed it and the guess was correct at the first trial and that's her luck. Now how about the multiplicative ciphers? We have something. We said that the Z is additive. The multiplicative ciphers would be Z26 asterisk. We will talk about what is the asterisk means. Okay. Now, for Alice want to send a ciphertext to Bob, or she want to encrypt the message. Now, what she will do, she will say, well, my plaintext multiplied by the number of the key mod 26 would be my encryption method. And of course, the other side would be decryption. Decryption would be equal to plain text multiplied by the k to the power of a -1 mod 26. Now, this k power -1 would be the inverse multiplicative cipher. Again, in the chapter 2 or in the video, I have explained what is the inverse cipher or what the multiplicative inverse means. Now, in multiplicative cipher, the plaintext and the ciphertext are integers in Z26. The key is an integer in Z26 and asterisk. لەوانەیە پرسیار بکەی بڵێ ئەو ئاسترەکتەمە بەسی لە چییە بۆ هەر ناڵێ the key and the ciphertext are in Z26 لەبەرەوەی لە کیەکە ئەمە key کەڕەت ئەەکەین and Z26 should start from 1 not from 0. That is the difference. و ئەمە لە کۆتا پیجی چاپتەری دووە لە کریپتۆگرافی کلاسە هە لە پی کە شاگە سێری بکەنەوە شتا بینە ناو. Let's see if we can find it. Cryptography. That's why I told you to watch the previous video very carefully because it is important. Okay. Chapter 2, take a look at here. Now, guys, take a look at here. It says that Z13 is equal to 0 into 12 because Z is equal to n minus 1. Start from 0 to n minus 1. N is the 13. Now, Z13 would be 0 to 12. If we count it, would be 1, 2, 3, 4, 5, 6, 7, all the way would be 13 digits. Now, however, the Z13 asterisk would be starting from 1 because we use the for multiplication. If we multiply something with 0, we will get 0. And so now we will try, we will use it, the Z13 asterisk or Z26 asterisk in this example. Where is it? Yeah, in this example, because we want to make sure that our multiplication will not be 0. Now, that's why, that's what this note means. Now, لو أنا ليرو توزك شتكاوا معقد كبير, but believe me, it's quite easy. Now, let's take a look at here. What is important is to know all of these numbers. What do they mean? We will now know. What's the key domain for any multiplicative cipher? The key needs to be in Z26 asterisk, as the set has only 12 numbers. 1, 3, 5, 7, 9, 15, 17, 19, 21, 23, 25. Now, what are these, guys? What do you think? Amana Chin, champion. Of course, this is for Z26. If this is Z13, for example, of course, it will change. We'll have a 27 and 29 also. اما او ژمارانن کە بەسەر یەکە یاخود بەس بەسەر خۆیانە دابەشە بن وایە 5 بەسەر 5 دابەشە بێ بەسەر یەکیشە دابەشە بێ هیچ ژمارێکی تر نییە کە بەسەریا دابەش ببێت و فراکشنی نەبێت. Is that correct? So
کام ژمارە و کام ژمارەیە
هەمیان
prime number أكانه.
they are the prime numbers. Exactly. 1 is the
بەس
prime.
ئێستا 21 خۆ بەسەر سێ دابەشە بێ حەوتەکە
بەسەر خۆیان باش بەڵام ئێمە شتێکی ترمان هەیە پرایم نمبەرەکان
بەسەر
کێشەیەکی تریشیان هەیە GCD کاتێککە greatest common divisor دۆزینەوە ئەگە سی ڤیدۆکت کرد دەبێ پێویستەکە ژمارەیەک هەبێت کە هاوبەش بێ لە نێوانیانە. Okay, ئەو ژماری کە لە نێوان هەمویانە هاوبەشە yes, it would be 1 at that time and this is fixed. ئەمە فیکسە ئەم ژمارانە they are fixed. Okay, لەوانێ بەسەر حەوتا دابەش بێ بەڵام بۆ نمونە 11 بەسەر حەوتا دابەش نابێت so it is not a prime for this set. So what you need to know that is Z26 asterisk has these 12 members. Okay, now why do I need this? You will know. Not for the encryption, for the decryption you would know. Now we have this ciphertext with the key of number 7. We want to encrypt the hello with the key of 7, and the ciphertext is this. However, how do I know that the ciphertext is this? I will take the hello HELLO. Now the edge is 7, 4, 11, 11, 14. Now the encryption would be 7, which is the number of the key, multiplied by 7, which is this. mode 26, we will get the ciphertext. Now the 4 would be the our position of the plain text or alphabet position. Now the key would be 7. As you can see, let me change it. Laser pointer, yeah. These are the keys. Why? Because we say that P multiplied by K. This is. Okay, now this is the position of these. Okay, if we multiply this and we mode 26, we get the 23. Okay, we will not again explain what is the mode and how we will do it and so on, because we explain it a lot. Now we've got this. However, how about the decryption part? Okay, now it doesn't talk about the decryption. Affine cipher. Yeah, it talks about the affine cipher. It's totally the same because we will use the same. However, he did not. Now, what you need to do is for the decryption, I will just tell you now, and we will explain it also in the affine cipher. For the decryption, we will do something else. We will not multiply by the key. We will multiply by the multiplicative inverse of the multiplicative. And what does this mean? So we have a list that tells us what are the multiplicative of these ciphers are. I have prepared, however, if you wanted, you can also go to the video and take a look at the multiplicative cipher and how we will get the multiplicative cipher of a specific number. Now, the multiplicative cipher of 3 would be 9. Okay, and so the 5 would be 21, the 7 would be 15. So in order to decrypt it, we encrypt it using the 7. However, we will decrypt it using the number 15. Okay, and of course, if you go to 15, you see that the multiplicative is 7. Okay, and in the video, I will explain also that the multiplicative cipher we should get the remainder of 1. Okay, we always should get the remainder of 1. Now, let's talk about the affine cipher. Affine cipher is also nearly the same idea of the previous one. However, we will explain it with this. Now, for the encryption, we have a 2 pair of key. Now, in here, we have only 7. And we say that the key of the key of 7. Okay, we have a hello and we use key 7 in order to get the plain text. Now in here we have 2 keys. However, the rule is like okay. Yes.
interactive شكل كاغوا مثلا برسياري هبو وساعات كيشة
Okay,
لا
Kagba.
مش بيولم ساعات بس نميز بيو.
Okay, we will start from the affine cipher at 10:13. Okay, affine ciphers. Now we talked about the multiplicative cipher, and we said that uh, in order to know the key domain for any multiplicative cipher, and in this example, Z26 asterisk, it would be these 12 numbers, and these 12. Sorry, Kagbja, you want to say something? Okay.
No, I was testing my mic. Sorry.
Okay, it's okay. Now, the set has only 12 numbers, and some of them are the prime numbers, and some of them are not. Okay. However, the main point in here is not only the prime numbers. Also, as you can see in here, as Mr. Muhammad said, Muhammad Kamal, that 21 is not a prime number. However, it is in this set. And in order to find out the multiplicative inverse of any number, I highly suggest that anyone that wants to know the multiplicative inverse of a number, rewatch the video of chapter 2 in the multiplicative inverse of 11 in Z26. You see in here it says 19. And if we watched it in the Excel sheet, we have 11, 19. So this is like a cheat sheet. Okay, it does not explain how did the key, its inverse became 19. It is only a cheat sheet that tells you that then this number's inverse is this. Okay. Now, if you wanted to understand how the 11 became 19, you should watch this 2 to 5 and study for this, or watch the view to video that I have uploaded already. Now, we use the multiplicative cipher to encrypt the message hello with a key of 7. The ciphertext is XCZZU, and the plain text is 0704111114. We multiply it by 7 more 26. This would be 49. 49 more 26 would be 23. And this is the multiplicative cipher. Now we have something else, which is affine cipher. Affine cipher is using two keys instead of one key. In here says the key, uh, in here the key is 7. Let me choose the laser. In here the key is 7. However, in the in the affine cipher, we will have two pair of keys, or a pair of keys, or two keys. Now, let's do the same example. However, the hello this time would be encrypted using two keys, 7 and 2. However, you should be aware that the H is 7, 4, 11, 11, 14. This is the position of each word. For the encryption, you will have this set of numbers in the first row, then multiplied by the first key, then plus the second key. If you did it this way, you said the 7 multiplied by 7 would be 49, and plus 2 would be 51. It is correct. But if you did it this way, you said the 7 plus 2 is 9, and 9 multiplied by 7 is 63. That would not be correct. Okay? Did you got it?
Yes.
Okay. Now, the main thing in here, just keep it in mind that the position of the plaintext will be multiplied by the first key and plus the second key, which has been explained in here. For the ciphertext, we have a plaintext position multiplied by the K1, which is key 1, and the K2 plus K2 mod 26. Now, how about the decryption? The decryption, we will have the position of the ciphertext minus key 2 and multiply by the inverse of the Q1. Now, this is the decryption. Now, ZEBBW, which is this one, ZEBBW 25.4.11.22. Now, we have 25.4.11.22. Now, in order to decrypt these words, we would say that the 25 minus 2, 2 is the second key, multiplied by the inverse of the first key. And the first key's inverse is 7. The key is 7, so you should find the inverse of it. Now we will get and of course, mod 26, we will get the actual uh, position of the keywords. Now we have example 3.12, the additive cipher, special case of an affine cipher in which K1 is equal 1. The multiplicative cipher is a special case of an affine cipher in which K2 is 0. Now we have a monoalphabetic substitution cipher. Because additive and multiplicative and affine ciphers have a small key domains, they are very vulnerable to brute force attack. A better solution is to create a mapping between each plain text character and corresponding ciphertext character. Alice and Bob agree on a table showing the mapping for each character. Now, if you ask me, how did the A assign it to N? I say that it is totally random. Now, let's say that you and Mr. Bawan will agree on that the A in our messages, A would be N, but B would be O. Now, it is totally by you, not following a privacy a policy or something. Now, if we used the before table, this message is easy to encrypt but hard to find the key because there is no specific key, okay? And there is no any key. This is why this one is quite hard. Now we have a polyalphabetic ciphers. In polyalphabetic substitution, each occurrence of a character may have a different substitute. The relationship between character and a plain text to a character is the ciphertext is one too many. What do we mean by this? If you take a look at here, yeah, at here, the word hello has two L, and their position is 1111. No problem until here. However, even if we encrypted these two L's, they would be 1 and 1. So the L's would be 1 and 1. Or let's say that the hello is 2O, it would be 1414, and of course the encryption would be WW. Now
But in
polyalphabet,
mono with different value.
sorry,
That's right. For repeated lines, in mono will be different, right?
no, it is the same for mono. However, for poly would be different.
Yes.
Okay, so now in polyalphabetic substitution, occurrence of a character may have a different substitute. Okay, now what do we mean by this? We mean that the L sometime might be A, in the second occurrence might be C. And why is that? We will explain. Guys, first of all, I will not explain this. I will explain using an example, and then I'll return back to the equations for make it easier to understand. Now, uh, this is an example. Assume that Alice and Bob agree to use an auto key cipher with the initial key value of k is equal to 12. Now, Alice wants to send a Bob message, attack is today. Enciphering is done character by character, or encryption is done character by character. Now, you see, this is the plain text. Attack is today. Now, the position of A would be 0. We know it. T19 and all the way. Now, the only thing, in order to create the key, we will not use directly the 12. We will put the 12 in the front of here. We will say 12, 0, 19, 9, and so on. Now, this is the key, as you can see. We put the 12 and then 0, 19, 19, 0, 2 is 2. We just shifted it this way. Okay, we just created a place for the 12. And so on until we get the end. Now, this is the key stream. So the key is not fixed. We only know the initial. However, if we know the initial, we can just remove the initial and shift it to the left one time, and then we will have the original plain text. Now, the ciphertext or the C values, okay, when we say P values, we mean the plain text values. When we say the C values, we mean the ciphertext values. Now, 0 and 12 would be 12. 19 and 0, any idea?
90.
19. Thank you very much. Because you see, for the ciphertext, ما طبعا هالوابو أصلا كاريه هنا ومتيراينا اللي راشها معنا.
بس
Okay.
أستاذ يكبر
Yes.
plain text value كان من آياته ولا الامتحانة؟
نعم. ما بخد بيزاني برام. إما اللي أي هتاوك زيد مان هي. وايا.
واه.
أي صفرة زيد بيستو بيانجا. اتلو بيناتو
يعني بو باترن نارو.
بلا باترن أو فيكسة. الكريبتوغرافيا أو باترن فيكسة. ساملا سلايدي 34. I think that we were in
لا زانم
shifted.
بس هو مزاني
Yeah.
راندوم
No, no,
نمبر
no, no, no. I'm a fixer. That's why I said that ciphertext is not correct. I'm a raznia. Now the A is 0, the Z is 25, and you should find this, or you should know it. Actually, it's not that hard, isn't it?
والله استنى
أقر
باش
أقر بتأتي أخذنا تأتي موضوع يعني. Now, in order to get the ciphertext, you will say the 0 plus 12 more 26. Okay, that's why the 19 plus 0 is 19. Okay, and 19 more 26 is 19. However, 19 plus 19 would be 38. Is that correct? Now 38 more 26 would be 12. And so on until we get the ciphertext. أو ciphertext كمان دسكو. Okay, now this is the encryption. We say that the P, which is the plain text place, and the key, we will plus these two, and we say more 26, we have it. Now, in order to get the decryption, emelera plus marker minus يبقى. Minus يبقى شو أنا أصلا كده سكوته. Now, we have something else. We call it Vigener cipher. And we will explain the Vigener cipher this way. We say that the encryption would be P plus K. However, PI plus KI. It means that the P will have one or more. Okay? One, one, two, two, three, and four, and so on. Now, إسبا جا بلبزاني نما ممثلي لتشي. Now, we can encrypt the message she is listening using the 6-character keyword Pascal. Okay. Now the value for Pascal for the P is 15. For the A is 0. Is that correct? And so on. أجيب أخير. Okay. Pascal P-A-S-K-A-L. بالي رود speaking. أما she's listening بمجورة داما ناوى. Alin P-A-S-C-A-L. P-A-S-C-A-L. And so on. Now, for the N and G, لبري وشا كمان بون منا الإرادة دوانزا alphabeta. Now, PNG يكم Pascal, PNG دون Pascal. دو دانيش would be PA. So, our key is repeating itself. خوي دوباره أكاتو. Now, أي اسم جا كويان كينو 8 كوي كينو مودي 26 كي ورقين كحوتك. حوتو 0 حوتو وەکو خۆیمێنێتەوە 4 و 18 ئەکاتە 22 هەشت و دوو ئەکاتە 10 ئەمە کۆکردنەوە نییە بەڕێزان ئەمە کۆکردنەوەی عفو جاڵم کۆکردنەوە نییە بەڵام لە پلیسێکە کاتێکاتە دوای 26 سفر ئەبێتەوە ناو لەم حاڵەتەیە 18 و 15 ئەڵێن ئەگەر دەکەی بخێنە سەر بێ بە 25 یەک دانەشی خێنێکە ئەبێتە بە 26 ناو لە 26 هەتاوەکو ئەم تاوەکو ژمارەکەی خۆی تەواوەکە حەودانێ نازانم ئەگەر if you understand it this way let me yeah. Now we say 18 plus 15 okay now by itself it would be 33 okay but however we have a simpler way in order to get it we would say that 26 minus 33 is equal to number 7. It's correct that we do not mod ناکەین بەڵام لە 26 ژمارەکە تێناپەڕێ کە ژمارەکەمان ئەگاتە 26 سفریەکەینەوە ئۆکەی کە گەشتە 26 سفریەکەینەوە جا ئەتوانین بڵێ 26 ناقسی 33 چۆنی تۆ 26 هەمیشە هەیە ئەم دوانە کۆکەرەوە ئەگەر بۆ نمونە ژمارەکە 25 کرد 25 کرد ئەدەوایز لی دەرکە ناو 11 و 11 22 کردووە هیچ کێشەی نییە هەتاوەکو 25 کێشەی نیە لە 26 سفرە بێتەوە and 4 و 2 6 13 صفر 13 8 و 11 19 and so on. However, this is why the 8 و 15 is حوت because we minused it from 26. Now let's see how can encrypt the message she's listening using 6-character keyword Pascal. The initial key stream is 15 1 8 2 0 11. The key stream repetition in the initial key. As we explained it that this is the plaintext value and this is the key. This is P A S C A L and so on. This is P and A. Now we will we will do the addition process over this and we will get this ciphertext. Now this is our ciphertext for where she is listening. It would be this ciphertext. Now also this is the same process, so we will now go with it. So as you can see, we type HSWKSW, HSWKSW. This one is quite simple also. This is simple. We will use only this. Now, as you can see, the P, the A, the S, the C, the A, the L. However, in here, it's much more easier to compare with this. Also, they are the same, but the illustration also makes it easier. Now, this would be the Vigener table low, or as we can see, and you can see that the additive cipher in special case of Vigener cipher in which M is equal to 1. We will now go through this because in the textbook has not been explained a lot, so we will not take any time over this. Now, let's assume you have intercepted the following ciphertext. Now, Mr. Bowen will intercept this text and will say, well, how to decrypt this? Now, in order to decrypt this, if we wanted to use Kaspersky test, we will do this. We say, well, I saw the JSU in the first index was 68. Okay. And the second index that I saw was 168. So 168 is in here. And the 68 was kind of, yeah, here's it. JSU. This is the index of 68 and this is 168. Now the difference is 100. The SUM is 69. Now SUM was 69. The other one was 117. The difference 48. And it will find the occurrences of the same words and the difference between them. Now, the greatest common divisor of a difference is 4, which means that the key length of a multiple for first try M is equal to 4. Now, he will try it this way, that way, and explain it that way, where the key is 4. It will take some part of the text, not the entire text. Okay, he will not take the entire text all. He will just, for example, take this part of it, and from here to here, from here to here, from here to here. So هەموو تێکچەکەکە بە 4 بەشەوە. Now تەوەقوعی چی ئەکات؟ کیەکانی وردە بۆی بیدۆزێتەوە. Now لە کی 4 now or the multiple of force M is equal to 4. Now it does kind of make sense because if you take a look at J U L I Julius US and CA and E, so it will be read it this way. So now it does make sense, and it is this. And for those, for example, one-time pad and this Visioner this way, some of them, for example, one-time pad, there's no any examples on it. By another word, the nalinka gringia, balku gringa, balku numunila sernia, bobika numunila sernia, we say that it is not that important, just like the Visioner. Okay, for example, in here, the Visioner, we know that how to encrypt and how to decrypt. However, in here, the one-time pad, there's no example of it. So basically, it means that it might not be that important by the author of the book. So one of the goals of cryptography is perfect secrecy. We know that. A study by Shannon has shown that the perfect secrecy can be achieved if a plaintext symbol is encrypted with the key randomly chosen from the key domain. This idea is used in a cipher called one-time pad invented by Vernon. Now we will talk about the transposition ciphers. Now we talked about the substitution ciphers. Okay, we said that substitution we will try to change the alphabet. For example, A will become C. For example, however, in a transposition cipher, we will not change it. We will just reorder it. We will change its place and we will put it, for example, in if it is in 1 1, we will put it in 5 5 or 2 3, the position of, for example. However, we will not make a c ay nakin basi lera ay her aya balam sho chomble tackle krao. A transposition site does not substitute one symbol for another. Instead, it changes the location of the symbol. Location is symbol agora. And symbol, we mean A, we mean E, we mean D, anything. Transposition cipher reorders symbols. Now, the topics that will be explained in here would be first, keyless transposition cipher, then keyed transposition ciphers, then combining two approaches. Now, before dive any more, do you have any question, guys?
No. No. No,
Okay,
thank you.
you're welcome. Now we have keyless transposition cipher. In the simple transposition cipher which were used in the past are keyless. A good example of keyless cipher using the first method is the rail fence. Okay, rail fence is the one of the examples that will be used and has no key. The ciphertext is created reading the pattern row by row. For example, send the message meet me at the park to Bob. Alice write meet meet me at the park. However, if we read it this way, MEMATEAK, we will not understand MEMATKE. Why? Because it is this way. Now, we have another example, which is this. So we can do it this way or this way. Alice and Bob can agree on a number of columns and use the second method. Now, the other one was the first method. Now, if let's say Ahmed and Ali agree on a number of columns, okay, number of columns, these are rows. However, these are the number of columns. Let's say they agreed on a number of column would be number 4. Okay, let's write the same plain text row by row in a table of 4 columns. وقتها اللي راح نروح حسابنا كين column حسابك بس column كذا بشيكين. Now we will write meet me at the park. However, لكاتي encryption كا أوا أنسره. Okay, this way and this way. MAMMTA MMTA EEHR EEHR, and so on. So the written would be this way, and the encryption would be this way. Now, the cipher in the example of 323, actually transposition cipher, the following shows the permutation of each character in the plain text into the ciphertext based on the position. Now, 1 is 1, 2 is 5, 3 is 9, 4 is 13, 4 is 2. Okay? Now, you see 1, 2, 3, 4, and we did not get 5. Now, between 1 and 2, we have a 3. Between 2 and 3, we have 3, 3 digits. Now, between 3 and 4, we have again 3 digits. The second character in the plain text has moved to the fifth position in the ciphertext. The second character moved to, and so on. So now the pattern permutation is 0, 5, 9, 13. Okay, 2, 6, 10, 13, 3, 7, 11, and so on. Now, if you take a look at here, 1, 2, 3, and 4. Now we got the 5. And 1, 2, 3, and then the fourth one would be 6. 1, 2, 3, now number of 7, and so on. Now, keyed transposition ciphers. The keyless ciphers permute the character by using writing plain text in one way and reading it in another way. Keyless بەشێوازێک ئەینووسی و بەشێوازێکی جیاوازی خوێنێتەوە بۆ نمونە لێرەدا meet me at the park بەڵام کاتێک کە ئینکریپتیەکە بەم جۆرە ئەیخوێنێتەوە MATAEEHREEAEK and so on. Yeah, and the plain text in a way and another way. The permutation is done on the whole plain text to create the whole ciphertext. Another method is to divide the plain text into a group of predetermined size. Okay, so dividing the plain text into predetermined size called blocks, and then use a key to permute the character in each block separately. The idea in here is we have a plain text. We will make it, let's say, 3 blocks. Now, these 3 blocks, they will be permuted character in blocks separately. Of course, using a key. Now, we say enemy attacks tonight. Enemy attacks tonight. Now, before explaining anything, take some moment and read this for me, guys. بەرەزانگ جۆتان لێمە؟
بەڵێ.
Now take some time and read this slide for me. Because from here, kind of, it is important to pay attention, full attention. كام سلايد بخوێنەوە لە پێشە؟ Okay, خوێنتانەوە؟
Yes.
Now, Alice want to send a message, enemy attacks tonight, to Bob. Okay, the word enemy. Okay. Now we have the enemy attack. The K became in here tonight. So 5, 5, 5, 5. So this is 20 symbols. أتواني جاتي alphabet بلين symbol كاتيكالين symbol ما بس مال E N E M Y. Okay. Now the key used for encryption and decryption is permutation key, which shows the how characters are permuted. Now the key for the encryption would be 31452. Okay, remember this 31452, and it has been used to encrypt. Now it is EEMYN. Okay, TAA, and became this. Now, if I told you how did this happen, you may not have any idea actually, because it is not وش كان همو كامل تيكل كراون. Now شلون بيدوزينه this way. Now please pay a close look at here. Now this is the word enemy attacks tonight. Now if you take a look at here, now the T, after T we added Z. Why? Because we want to make sure that it would be 20 characters, and we will add that Z. او Z هلا كنت هر معناه نابه تاقد مسجك كامل بشكريته ازان كو Z هر زياد كراو. Now we will write it row by row. Enemy attack tonight, attack until here and just tonight. We will write it. Okay. We will write enemy in the first row. Then attack at here, attack. And as we see the K, S, and N, the K, S, T, O, and N, and so on. Now, once we did this, based on the key 31452, we will take the 3, which is column number 3. So this is column number 1, number 2, number 3, number 4, number 5. Now, this is column number 3. Okay, we will put it in the position of 1. Okay, column number 3 into position of 1. Now we have 1. Okay, the first column. We will put it in the second. Why? Because based on this. Now we have the third one, which is a 4. We will make it in the place of 3. Now 4 made in the place of 3. Now the 5 would be in the place of 4. Place and 4. And the 2 would be in the place of 5. 2 to place of 5. Now read the column by column. EETTH, EETTH, and so on. Now this is our ciphertext. We will transmit it. We will send it to, let's say, one of us, one of our friends, and then he will get it. However, he will try to reorder it. Okay. Now it says that the first line that I have is the 3. It was in the place of 3. Okay. So the first line will be in number 3. Now the second one would be in 1. The second line, that the second column كأنه سم أشدو بشنا أصدقي خوي كيكا. Now the third one, the third line that I have was 4 in the لراستي دا page encryption. Now I will return back to 4. Now the fourth line would be in the number 5. I will just reorder it into number 5. Now the fifth column will return back to its original place. Now, now I have a question to ask you. Now we did the encryption and we did the decryption. However, which one of these keys were given to us? What do you think? Was 1, 2, 3, 4, 5 or 3, 1, 4, 5, 2?
Can you
Yes.
repeat the question again?
Now, my question is, we used 3, 1, 4, 5, 2 to encrypt the message. Is that correct?
Yes.
And we
Yes.
used 1, 2, 3, 4, 5 in order to decrypt the message. Is that correct?
Yes.
How did we know that it would be 1, 2, 3, 4, 5?
Because it was given to us.
No, it will not be given. For example, in the exam, they will give you enemy attacks tonight, okay, and they will give you, they say make it 4, make it 5, okay, as in here, make it 5. They will tell you also this. Of course, let's say that the last one would be 3, so you will add ZZ, okay. دا بۆ ئێمە بوو شەکەمانە 5 کردو بەشت پێ ئەڵێن بۆ نمونە ئینکریپشنەکەشت ئەکرێ پێ بڵێن بەڵام دیکریپشنەکە ئەکرێ پێت نەڵێن ئەزانن بۆ لەبەری ئەگەر پێت بڵێن یاخود پێت نەڵێن دیکریپشنەکە ئەو شێوازە فیکسە لەوری ژمارەکان لە 1 2 3 4 5 دەست پێکەن وایە ئەمە لێرە وتومانە چی وتومانە سێمان بۆ بخەرە شوێنی یەکەوە ئەمانە 1 2 3 4 و 5 هەیە باشە ئەمە فیکسە ئەمە 1 2 3 4 5 6 7 ئەڕۆژ تا ئەو شوازە ئێمە ئەڵێن ئەم شوێنی پێنجە بۆ نەم شوێنی سەیە بە چواری بچێتە ناو کاتە ئێمە ئەمە ئەگۆڕین ئاگادار بن هەتا ئەگەر نشتانە نێ ئەمە لێرە بۆ ئەم جۆرە نمونانە فیکسە بێت ئەکرێ نمونەیەکی تر بهێننەوە کە حاڵەتێک تایبەتی هەبێ هەرچەنە لە ئەم جۆرانەیە تقریبن هەر فیکسە بەڵام ئەمەیان لە دیکریپشنەکەیە هەمیشە هەر بەم جۆرە دەرەچێ بۆچی لەبری ئەمە ئەم کلیلەمانی راوەتێ ئەڵێ 3 1 4 5 2 واتە کۆڵمی سێ کە ئاوا کردوتە بە کۆڵم سێهم با لە یەکەمین ڕۆی تازایە بێ لە یەکەمین کۆڵمی تازایە بێ یەکەم کۆڵمت کە دەست کەوتووە بیکەرە دووهەم دانەوە بیکەرە دووهەم شوێنەوە با بڵێن ئەمە ئیندێکسەکانێتی چوارەم دانە کۆڵم کە دەست کەوتووە ئەمە بیکەرە سێەوە بۆ لەبەرەوەی ئەمە یەکەم دانێ ئەمە دووهەم دانێ ئەمە سێم دانێ چوارم دانێ ئەمە پێنجم دانێ so kind of this one is fixed kind of ینی سایەنەوەنووی کاتەکان بەڵام ترەکرێ حاڵەتێکی جیاواز لە ناو پرسیارەکە so reading the question would be super necessary. Do you understand how does the encryption and the decryption works?
Yes.
Okay, if they give you a key, any key, what you would do, you will write that key this way, and you will write it also the numbers in this sequence 1 2 3 4 5 ئەگەر لە پرسیارەکە ئاماژیان بە هیچ شتێک نییە ڕێک بەم جۆرە بینوسە ئەگەر ئاماژیان پێدا و کاتە جیاوازە بەڵام با بڵێن ئاماژیان پێ نێئەوە با لە جاتی ئەوەی بڵێن بۆ نمونە ئینکریپشن کیەکەمان 452 با بڵێن 500 با بڵێن 5 و سێکە جێگانێنە گۆڕنەوە ئۆکەی 5 1 4 3 2 this way and this time it means that ئەم بلۆکی کە دروست کردو بە بلۆک هێناوتن ئابم شازە ئەم پێنجە بۆم خرە یەکەم دانەوە بۆ لەبەری یەکەم دانە هاتووە ناو ئەڵێ یەک دووهەم دانە هاتوو دووهەم ئەلفەبەتە ژمارەی دووهەمە بۆم کەرە ئەمەوە چوار سێهەم دانە هاتووە کاتە بیکەرە پۆزیشنی سێوە ئەمە پۆزیشنی سێ لێرە ئەمە پێنج نییە بێ بوو بە سێوتمانی گۆڕینەوە سێ سێ بیکەرە پۆزیشنی چوارەوە کاتە ئەم سەیە کەینە پۆزیشنی چوارەوە بەم شێوەی ئینکریپت دەکرێ وە بە پێچوانەکەشیەوە 1 2 3 4 5 ئەم کاتە چیت دەستکەوتوە کاوانت کرد بە بڵۆک ئەڵێ یەکەکە بیگەڕێنەوە بۆ شوێنەکەی خۆی هاوەڤە نایبن بۆ سێ لە منوێتمان پێنجەکە شوێنە گۆڕبن ئەیبن بۆ پێنج and so on Now this was the uh, encryption key, and we talked about the decryption key. Now in example 327, single key was used. Okay, this one was single key in two direction for column exchange, downward for encryption and upward for direction. It is a customary to create two keys. يعني اشتكي باشا كدو كليل دروسكي. Okay, so now we have another example. أما حالة زور زۆری سراحەتەکە ئەوەیە کە یەکشی بدرێت هەر ئەوەی کە کی یەکەمی یایتێ لە خوارەوە بە 1 2 3 4 بڕۆ پیاە تاوەکو وەی دۆزیتەوە. Now how about the if we had two keys? So you now see 31452. Now we have 25134 for the decryption key. Now we have 1 2 3 4 5. We have 1 2 3 4 5. Now it says 1, put it in the place of 2 for the encryption, and 2, put it in the place of 5, and so on. Now we will explain it here. Now we have an encryption key and we have a decryption key. جماعة ليرة پێویستەکە کە زۆر باش ینی تەرکیزتان هەبێ. ئەمە encryption کیەکەمانە 2 6 3 1 4 7 5 2 6 3 1 4 7 5. Now we will add the index 1 2 3 4 5 6 7 بۆ لە بریش گەورترین ژمارە لێرەیە 4 ئاڵێن لە 1 2 3 4 5 6 7 وار خۆشی حەوت ژمارێ با نەژڵێن گەورترین ژمارەچکە بێ گەورترین ژمارە نییە حەوت دانەیە حەوت دەجێتە 1 2 3 4 5 6 7 ئا لێرە لە 1 2 3 4 5 6 7 ڕیزی ئەەکەین ئەمە تا ئێرە هەر سنگڵکیەکەی پێشووە ئا لێرە اینجا عکسی کەرەوە سواپی بکە ئەم ڕیزە بەرە ناو خانە پرتەقاڵیەکە خانە پرتەقاڵەکە بێنەرە خوارەوە. As you can see now 1 2 3 4 5 6 7 اینجا عکسەکەی 2 6 3 هاتوتە ئێرە. لە دوای ئەوەی کە ئەمەمان کرد اینجا چیەتە پێشەوە ئەوەی کە سۆرتیان بکەین. ئێستا ئەم ژمارەی ترمان چۆن دەستکەوت لە ئەم ژمارەیە چۆن گەشتینەوە ئەم ژمارە ئەڵێن 4 is in the first place. Okay, now 1 is in the second place. Now 3 is in the third place. 3 key is the fourth key is in the 5. The fourth key, for example, in here, and it is in here. Okay, and we'll write it this way. Now take a look. جوان سەیری بکەن پرۆسەکە دەست چۆن عکسمان کردوتەوە لە پێشا ئینکریپشن کیەکان نووسین 2 3 4 5 6 دەنووسین دوای سواپیانەکەین ئەن دوایی بە پێی پۆزیشنەکەی ئەڵێن بیکرە ئەویاوە. Now چه پرسیاری هەیە ئەڕێزان؟
دکتۆر بەتەوە بەشی سوابە باسێکی تازێنەبێ.
سواپەکە تەنها یەک شت ئەەکەین. سەریکە this is our encryption key. We will write it in this orange rectangle. Okay, we did nothing. We only wrote this in this orange rectangle. Now we will write 1 2 3 4 5 6 7. Why? Because these are ئەمان هەر خۆشیان حەوت دەجێتن 1 2 3 4 5 6 7. تا ئێریش کێشە دێ؟
کێشەم نیە.
اوكي ئێستا جێگەی ئەم ڕیزە لەگەڵ ئەم ڕیزە عکسکەرەوە ئەم بێنەرە ئێرە ئەو بێنە ئێرە. اوكي ئێستا 1 2 3 4 5 هاتوتە سەرەوە and 2631475 هاتوتە خوارەوە ئێرە کێشت هەیە تەنها جێگەکانیان گۆڕاوە ئەم ریزە براوتە سەر و هێنراوتە خوارتر
تا ئێرە تێگەم دوایەوە
باش. Now I would say that the number one would be in the second place. يعني چی؟ يعني ژمارەیەکم بۆ بخەرە کۆڵمی دووهەمەوە باشە ئەی دوو بیکەرە شەشەمدانەوە ئەی سێ بکەمە کوێوە
کەرە سێم
باش ئەی چوار بیکەمە
چوار کە یەکەمە
بیکارە یەکە وایە یەک کوێ ئێرایە وایە
یەکەم
ئەی
بەڵێ
پێنج
پێنج هەبی کە چوارە بوو
ئەمە یەک دوو سێ ئەمە چوار ئەوە پێنجمانتانە ئەی شەش
شێبی کە ئەخیرەوە
شەشمان کردە ئاخیرەوە ئەی حەوت
ئەوتیش بیکەرە شەشەوە
باش حەوت بۆ بیکەمە شەشەوە حەوت
نه
ئەیکەمە
پێنج
ئەیکەینە پێنجەوە Now 1 2 3 4 5 6 7 ئەمە کرمانە پێنجەمە Now ئێستا هیچ پرسیارێک تێ
دەست خۆش دوتر
کەواتە حەوتەم ژمارە حەوت کردومانەتە پۆزیشنی پێنجەوە یەک دوو سێ چوار ئەمە پۆزیشنی پێنج حەوتی تیادا بنێ ئۆکەی کاک باوەنەنی کوەسچن
دەستەکانە خۆش ئێستاسی
یۆڵکەم ئەگەر شتێک هەیە
قاموزە
کوێی چ بەشێکی
وەڵاهی ئەو سۆرتە نازانم زۆر لی تێنا
سۆرتەکە هەر ئەو کلیلەی ئەو بەرەوەی باشە ئەنی قسەکەەوە ئێمە چۆن گەشتین بەم کلیلە وایە لێرە پێگەیشتین ناو سێریکە ئێمە ئینکریپشن کیەکەمانە نووسین بە let me open a notepad بە هەردووکیانتان لەبەر چاوە بێ what is our encryption key is 2 6 3 1 4 7 5 باشە ئەمە 1 2 3 4 5 6 حوت ئەمە هیچ شتێکی تیانێ وایە با بڵێن کیەکە با بڵێن نۆ ئەو نەبایە ئەمە ئاوا یا با نۆ ناوەڵا با بڵێن یەک چوار بۆ نمونە مانوت هەشت نۆ ئەمە ئەڕۆی ئەمە هەر ژماری ئاسایی و ئەڕوا ئەمەش کلی لەکەمانە ناوبا ئەمە بسڕینەوەی تێکەڵ نەبێ لێمان ئەمەش سڕینەوە ناو هەتا ئێرە هیچمان نەکردو ئیشی دووهەمی ئێمە چییە با خەتێ بێنین بە ئەم پلەسە لێن نای ئیشی دووەم ئێمە ئەنجا عەکسی کەینەوە اینجا بڵێن چی 1 2 3 4 5 6 بڵێن 1 2 3 4 5 6 حوت اینجا ئەم کیە بێنینە شێری یعنی چیمان کردە بەس عەکسمان کردەوە تۆ ئەسڵەن ئەتوانیت هەر لە هەوڵەوە یەکسەر ئەمە هەر نەنووسی هەر یەکسەر 1 2 3 4 5 6 حوتێ بنووسە و یەکسەر بە دوایە لە ژێریەوە چۆن ئەمە 1 2 3 4 5 6 حوتێک نووسیەوە ئەوە کلیلەکە لە خواریەوە بنووسە یعنی تۆ توانی ئەم ستێپە هەر نەکەی
ینی ئێستا بۆ نمونە 1 2 3 4 5 6 حوتەکە بوو بە سایفەر تێکست وایە
ناجارێ هیچمان نەکردو جارێ ئەم دەقەیە هیچمان نەکردو ئێمە بەس چیمان هەیە تۆ هەر ئەسڵەن هەر ئاوابی کەکەک باوم هەر هەمان شتە ئەسڵەن ئەم ستێپە لەبری بەرامبەر یەکەوا کردوتیچنا هەر خۆی زیایە ئەمە ئاڵین کاکە ئەمەمانێ 1 2 3 4 5 6 حوت ئەی ئینکریپشن کیەکەمان کووە ئەڵێن 2 6 3 1 4 حوت 5 ئەمە ئیتر تۆ ئەوە هەرواز لێبێنە باشە 1 2 3 4 5 6 حوتێکە نووسیەوە ئەمەشە نووسیوە باشە ئەم ستێپەی ئێرە ئەڵێ چی ئەڵێ یەک لە پۆزیشنی دوایە
دووەدا
ینی ئێرایە ئێرە بهێنرە ئەم یەکەم بۆ بخەرە پۆزیشنی دووهەمی ئەو شوێنی کە داتناوە کلیلەکەی کە داتناوە دوو بیکە پۆزیشنی شەشۆ ژمارە دوو خۆی نەک بڵێ پۆزیشنەکەی سێ بکەرە سێ چوار ژمارە چوارم بۆ بکەرە پۆزیشنی یەکەوە okay
تێک
5 make it in 4 now this is 5 and if we calculate it 1 2 3 ئەمە 4 ئەڵێن ژمارە 5 کەرە خانەی چوارەوە ژمارە 6 کەرە خانەی حوتەوە ژمارە 7 خەرە خانەی پێنجەوە و هەر بۆ جۆرش کردوێتی ناو ئێستا تێگەیشتی قسەکە گەیشت
دەسەکان نەخۆش ئێستاس
سەلامت بیبرە
هەبزان
نا
کاتەکەش وردە تاوێ
ئەمە باسەکەنم مەترسەسە و تەواو بوو لە بروی ئەگزامپڵی دوای ئەوە ئەچینە سێ چوار یەک سێ چوار دوو ئەمانە باز ناکەن بێگومان هەر هەمان فکرەیە و هەمان مۆزوعە ئەمە باسەکەینەوە ئێمە پلین تێکستێکمان هەیە باشە ئینکریپشن کیەکیشمان هەیە ئینکریپشن کیەکەمان چەند بوو 3 1 4 5 2 3 1 4 5 2 ئێسمە پلین تێکستەکە هەر ئێنەمیەکەی هەر ئێنەمیەکەی هەر هەمان شتە بەڵام لە جیاتی ئی کردی بە سفر چوار ئەزانین کە ئی پۆزیشنەکەی چوارە باشە ئێن سیانزێ ئێم ئی دووبارە چوارە ئێم دوانزەیە وە سۆ ئەمانی بۆ دروست کردوین کیەکیشی دروست کردووە کلیلەکەڵە چی ئەڵێ مادەم سەیە لە پۆزیشنی سیا یەکدابنی ئەوانەی تر بە هەمووی سفر ئەمە لە پۆزیشنی یەکە یەکدانە یەکدابنی ئەوانەی ترکە بە سفر ئەمە بڕۆ 1 2 3 ئەمە چوار بۆ ژمارە چواری پیاوانی ئالا یەکێکدا بنێت ئەوەی ترکە بەسفر ناو 5 هەر هەمی باسفر بێ خانی پێنجەمی بەس با یەک بێ هەز بە یەک و سفر بڕێگەیتەوە بەڵام یەک لەکوێ دانەی بە پێی ئەمە ناو تو ئەمە دابنێ ئێستا بۆ ئەوەی کە سایفر تێکساکەم دەستکوێت چی ئەەکەم ئەڵێم چوار مڵتیپلاید بای 0 سیانزە مڵتیپلای بای 0 چوار مڵتیپلاید بای یەک باشە ئاوە ئەم ڕۆیە زەربی ئەم کۆڵماکەم ئەو ڕزڵتی کە دەستمەکەێمە ئەیکەمە یەکیەکەوە ئەی بۆ یەک دوو چیەکەم هەمان ئیش دووباراکەمەوە ئەمە زەربی ئەماکەم بۆ ئەڕۆم هەتاوکو گەمە نەتیجە یاخیر کە گەشتمە نەتیجە یاخیر ئەمەم دەسەکەوێت Did you got the point or do I need to re-explain it? Do you think that
تێگەیشت
the main idea is like this and ئەگەر فۆڵی ئەم خەتانە بکەی زۆر جوان نین بەڵام بۆی کردمە بۆی کە لی تێ بکەن 4 multiplied by 0 13 multiplied by 0 4 multiplied by 1 12 multiplied by 0 24 multiplied by 0 هەموو زیرۆکان سفرەکەن ئیلا یەک شوێن نەبێ وایە ئەو یەکە کەرە یەکەکەەوە ناو ئەی یەک دووچی ئەمە چۆن بدۆستبوو ئەو ڕیزە زەربی ئەم ڕیزەیەکیت باشە ئەمە زەربی ڕیز دو ئێستا سێری یەک دووکە چوار کڕەتی یەک چوار کڕەتی یەک ناو سیانزە کڕەتی سفر سیانزە کڕەتی سفر ناو 4 multiplied by 0 4 multiplied by 0 ئیترەوە هەمووی بێ بە سفر ئەو بەم جۆرە ئەڕۆی هەتاوکو ڕیزی یەکەم پڕەکەیتەوە بۆ ئەم ڕیزی یەکەمە زەربی 1 2 3 4 پێنجی ئەەکەی تاوکو و ڕیزە پڕەکەیتەوە ئەی ڕیزی دوو هەم زەربی هەر پێنجیانەکەیتەوە تاوکو و ڕیز دوم پڕەکەیتەوە ئەی ڕیزی سێ هەم زەربی ئەم پێنجەکەی تا ئەم ڕیزەش پڕەکەیتەوە ڕیزی چوارەم زەربەکەیتە تاوکو و ڕیزی ئاخیر پڕەکەیتەوە ناو هەر هەمان فکرێ ئەوەی لێرە ئەوەی کە لێرە نووسراوەمە تەنها ئەمانم بۆ زیاد کردو ئەمە لێرە هەرمان شتە و and double transposition cipher we will stop in here in the 3 4 stream and block ciphers Okay, we will not explain this one. I will create a video for you, and then I will attach it with this one. Okay, with this video that I will be uploaded to YouTube. Double transposition ciphers. In figure 325 double transposition cipher, we have the word enemy attack tonight. We added Z to the end. Now the write row by row, and then permute the column, then read the column, read column by column. Now this would be the middle text. Then again, write this row by row, then permute the column, then you would have the read column by column again and the ciphertext. Then this would be your final ciphertext. Now this would be called a double transposition cipher. The previous one was only transposition cipher. Now this one is double because it would be two time and permuted. And then again, what you did in here, it should be uh, reversed, right column by column. Here it was read column by column. No, in here it be the right column by column, then permute column, read row by row, and then middle text. Then do the same process, and you will get your ciphertext. Now we have stream and block ciphers. The literature divides our symmetric cipher into two broad categories: stream cipher and block cipher. Although the definition are normally applied to a modern cipher, however, this categorization also applies to the traditional ciphers. We will have a stream cipher, then a block cipher, then the combination. Now, stream cipher call the plain text stream P, and the ciphertext stream C, and the key stream K. So P will be equal to P1, P2, P3 into the end. Then our C would equal to C1, C2, C3. And the K would be equal to K1, K2, K3, and so on. Now the C1 would be E encryption with the K1, P1. This part of the, let's say, the P1. Now the P2 would be with K2, and that would be our ciphertext. Now C3 and so on. Now this would be our stream cipher. We will take the plain text and the keys and the ciphertext. We will have the plain text fed it to the this encryption algorithm. We will have EK3, for example, A, and then we will have our ciphertext. Now we have 341 continued. Example 330. Additive cipher can be categorized as a stream cipher in which the key is the repeated value of the key. And in other words, the key stream is considered as a predetermined stream of a key. K is equal to K, and so on. In the cipher, however, each character in the ciphertext depends only on the corresponding character in the plain text because the key stream is generated independently. Now, example 331 would be the monoalphabetic substitution cipher discussed in this chapter are also stream ciphers. Now, however, each value of the key stream is in this case our mapping of the current plain text character to the corresponding ciphertext in the mapping table. 332 Visionary cipher are also stream ciphers according to the definition. In this case, the key stream is repetition of m values, where m is the size of the keyword in other words. Now the k is equal to k2 and 3 and m until it reaches m. Now the k1 again repeats itself until the end. Example 3.33 would be we can establish a criterion to divide the stream cipher based on their key streams. We can say that the stream cipher is a monoalphabetic cipher if the value of a key ki does not depend on the position of the plaintext character in the plaintext stream. Otherwise, the cipher is polyalphabetic. So this is how you can say that the cipher is the mono or the polyalphabetic. Example 330, additive cipher are definitely monoalphabetics because the ki or the key ki in the key stream is fixed. It does not depend on the position of the character in the plain text. Monoalphabetic substitution ciphers are monoalphabetic because uh, uh, key does not depend on the position of the corresponding character in the plain text stream. It depends only on the value of the plain text character. Vigenère ciphers also polyalphabetic cipher because key I define it definitely depends on the position of the plain text character. However, the dependency is cycle, and the key is the same for the character position apart. Now we have the block cipher. In the block cipher, a group of plain text symbol of a size of m, and of course m is greater than 1, are encrypted together, creating a group of ciphertext at the same size. So as you can see from here, the plain text is PLAENT and in this group plain text symbol, they will be all this block will be encrypted together. This block will be encrypted together, and also this block would be encrypted also together. Now, as you can see in here, we have a D, P, and V. The set is equal to encryption of a using the key of I and T, and this would be the encryption algorithm. Now, example 333, 334, 335, Playfair cipher are block ciphers. The size of a block is m equal to 2, and two characters are encrypted together. Now, Hill ciphers are block ciphers. A block plain text of size of 2 more encrypted together using the single key or a matrix. In the cipher, the value of each character in the ciphertext depends on all the value of a character in the plain text. Although the key is made of m multiplied by m value, it is considered as a single key. From the definition of a block cipher, it is clear that every block cipher is a polyalphabetic cipher because each character in a ciphertext depends on all characters in the plain text. And in combination, which is the last one, in practice, a block of plain text are encrypted individually, but they use a stream of keys to encrypt the whole message block by block. In another word, the cipher is a block cipher when looking at the individual blocks, but it is a stream cipher when looking at the whole message, consider each block as a single unit. And this would be the end of this class. If you have any question, you may ask in our next session in the online meeting. Thank you.